All right, here's our next example. We have given n equals 42. 42 meets the sufficiently large requirement. We're given mu 88.1. We're given sigma 14.4. And we're asked to find two pieces. Number one, find the probability that x bar is greater than 90, and find the probability that x bar is between 83 and 86. And so because the sample size is sufficiently large, we have met the requirement for the central limit theorem, and so we may use the normal curve to find this. And so we'll do each in turn. Z scale and the x bar scale. That's a Z. Center, where's the center? The center is the population value, 88.1. Standard deviation is 14.4. I just write this here so I know where to look to find it. And so our task number one is to find, well, see, what are we looking for? Looking for the probability x is greater than 90. And so that goes over here is all we need. But which side where does the squiggly line go? We want everything bigger than 90. So we're looking for that region, which corresponds to that region. But which way does the arrow go? Remember, for our table, the arrow always goes to the left. So do we see what's going to happen? When we find this value, it does not match what we're looking for. So this is where we need to take this value. 1 minus that is going to give us the little piece that we do want. So we have a little arithmetic to do at the end of this problem. So let's just go ahead and run down the list here. First thing, translate from x bar to the z scale. So this is x bar minus mu over sigma over square root of n. You do not need to have this formula memorized. Anytime you use it, that formula will be given to you. But what you do need to do is be able to know when do you use one or the other. This is used if you're looking for sample means. The symbols make a difference. The sample means, this is x bar, so use the x bar formula. Always before we had one single data value, that's when you're using the one on the right. Also a good tip-off is if you have a sample size, then typically, you have the sample size, you're going to use the formula that has the sample size. If there's no sample given, if we're just saying a data value is taken from the population, a data value means one data value. That's one data value, and this is the one we're going to be using. So here we do have a sample size 42. We are using this one on the left, and so now this becomes substitute and simplify. X bar value is 90. Minus the mean is 88.1. Over sigma is 14.4 over the square root of 42. Compute. So make sure you can make your machine find that value. I'm going to open parenthesis. Minus 88.1, close, divide by, open, 14.4. divided by the square root of 42, close, and I have 0.55. I'm going to round that. I'm going to round this to 0.855, so that's 0.86. Again, if the machine that you're using, if you round in slightly different locations, you get slightly different values. If you get 0.87 or 0.85 or 0.84, I am fine with that as long as you show me what you're doing. But what you should not get is something like 15 or something like -8 or something. So 0.86 goes here. I need the table value for 0.86. So I have 0.86, 0.86. I have 0.8051, 0.8051. 0.8051, the table value, that goes on the arrow. That is not what we're looking for. We want to find everything else. So our value we want, so the probability that x bar is greater than 90 is given by 1 minus 0.8051, 0.1949. If my arithmetic is correct, I get 1949. Ooh. Let me double check that just to be sure. 1 minus 0.8051, 1949. All right? Now in the next video, we'll do the second example.